Okay, now that you've taken your notes on arithmetic sequences, we're going to practice writing the both explicit and the recursive formula for each. Okay, we're going to start by using some of our notation. We know that a sub 1 is the first term. In this case, my first term is 1/2. Next, we need to find the common difference, which is notated using the letter D. We talked in class, we can find the common difference by taking the second term minus the first term. So here we're going to do 1 minus 1/2, and that gives me 1/2. So my common difference is equal to 1/2. A common difference of 1/2 means that to get from one term to the next term in the sequence, in this situation, we're going to have to add 1/2 because the 1/2 is positive. So the recursive formula, your recursive is written in terms of the previous term. In your notes, we know that the previous term is annotated using a sub n minus 1. So for your recursive, the current term is equal to the previous term plus 1/2. That's your recursive formula. For your explicit, okay, we're going to start with the general form, which is a sub n, current term equals first term plus term number minus 1 times the common difference. All right, so a sub n is equal to the first term, which is 1/2, plus n minus 1 times the common difference, which is 1/2. So this is a sub n equals 1/2 plus, use your distributive property here, 1/2 n minus 1/2. Combine your like terms. These cancel. A sub n equals 1/2 n. So that is your explicit formula. So now if I wanted to find the fourth term, a sub 4 would be equal to 1/2 times 4, which is equal to 2. And if you go back up to your sequence, the fourth term is 2. To find the 58th term, you do a sub 58 is equal to 1/2 times 58, which is 29. So the 58th term in that sequence is 29. Okay, for your second example, our first term is -8. To get from -8 to -15, we're going to have to subtract 7, subtract 7, subtract 7. Or remember that your difference is always the second term minus the first term. So -15 minus a -8 gives me a -7. So my common difference then is -7. That's my difference. And here's my first term. So for the recursive, the current term is equal to the previous term minus 7. All right, for the explicit, the current term, it's not very clear, is it? All right, the current term is equal to first term plus n minus 1 times the common difference. So the current term is equal to -8 plus n minus 1 times a -7. We're going to use our distributive property. You're going to have -8 minus 7n plus 7. So the current term, combine your like terms, is -7n minus 1. So that's your explicit form. Okay, to check it, let's find the third term. A sub 3 equals negative 7 times 3 minus 1, negative 21 minus 1. A sub 3 equals negative 22. And if we go back to the original sequence, the third term is negative 22, so that means that my explicit form is correct. Okay, for the third example, all right, we know that the first term is 18. The difference will be the second term minus the first term, 20.5 minus 18. And your difference is 2.5. Your recursive current term is equal to the previous term plus 2.5. Your explicit, so current term is equal to the first term plus n minus 1 times d. And if you want to, we can rewrite this and we can make it d times n minus 1 plus a sub 1. That may be a little bit more friendly looking. That's a sub n equals 8. The common difference is 2.5 times n minus 1 plus 18. 2.5n minus 2.5 plus 18. So my current term is 2.5n. And you're going to do 18 minus 2.5 plus 15.5. Okay, so that's your explicit form. We can check it by finding the fourth term. A sub 4 equals 2.5 times 4 plus 15.5. All right, when you work that out, this is 10 plus 15.5. And we get a sub 4 equals 25.5. And you go back to your original sequence, and the fourth term was 25.5. So what we have here is correct. Now, let's do a quick review of all the different notations. All right, so we know that n is equal to the term number. Okay? When we're talking about term number, that means whether it's the first term, second, third, fourth, fifth, however it falls in the sequence. Okay? D is equal to common difference. Okay? A sub 1 means first term. Okay? A sub 10 would be the 10th term. So whatever number is a subscript, which is this small number with the variable a, tells us the position of that term. Okay? And then a sub n just means the nth term because we don't know which one. Okay? A sub n minus 1 equals the previous term. Now, I've referred to this nth term as being the current term because that's the one that we're talking about. So a sub n is the current term, And a sub n minus 1 means the previous term. Previous because minus 1 takes us back 1. So if a sub n is the current, if I subtract 1 from it, I'm going to the previous term. Okay, now after reviewing these examples and taking your notes, I think you should be ready. Make sure you write down any questions that you have for me, because you will have homework problems to complete using the video.